With complex numbers, there are three different things that we did with these. First is adding and subtracting complex numbers. Remember to always treat the i's when you're adding and subtracting complex numbers as you did your x's. So here, if these were x's, first thing we'd say is, you know what, these parentheses really aren't doing anything for me. All they're doing is telling me where each complex number begins and ends. So our job is to get rid of them. This one, it really doesn't have anything in front of it, so we're just going to drop them. The second one, however, is preceded by a negative sign. And so in order to get rid of those parentheses, we're going to have to distribute by a -1 here. It's -4 plus 2i when we distribute that. Now we're ready to combine. Remember, all complex numbers should be written in this form, where a is the real part and bi is the imaginary part. Okay, so the real part of this, if I were to combine our two real parts, is going to give us -2. When we combine the imaginary parts, we do end up with plus 5i. That's an example of adding or subtracting complex numbers. Our second example will show you how we take a product. 3 minus I and 2 plus 3i. Okay, when you take a product, again, treat them exactly as you did x's. Start by distributing the 3 onto the second parentheses. 3 times 2 is 6. 3 times 3i is 9i. Then move over and distribute the -i onto the second parentheses. -i times 2 is -2i. -i times 3i is -3i squared. All right. This looks like it's ready to be combined as like terms. The one thing you need to be very careful about is, remember, when we wrote our answer form above for all complex numbers, we said it was a plus bi. There were no I squares there. You'll have to remember a rule that we showed you in class that said, you know what, I squared is the very same thing as a -1. So you're going to cross it out, replace it with the -1, and immediately, don't wait, multiply these two together. -3 times a -1 is a +3. It's real easy to make a mistake and assume that that's a -1 at the end of the statement if you don't go ahead and take the product right off the bat. So go ahead and do that. 6 plus 3 now are real parts. We're going to give us a real part of 9 in our final answer. Our imaginary parts combine out to be 7i. So there's our second example. The last topic that we want to cover with complex numbers is the division of complex numbers. Remember, when you're dividing by a complex number, the idea is that we do not want to have an I, which comes from a radical. And remember, same difference there. We don't want radicals or i's in our denominator, so we could either multiply through by, if it were a single-term phrase, by an I to clean that up some, or if you have a two-term phrase in your denominator, by its conjugate. 3 minus I is the part of the denominator that's bothering us here, so what we're going to do is multiply by his conjugate. Remember, the conjugate is exactly the same statement, but with a different sign in the middle. If the denominator has a minus there, we're going to multiply through by 3 plus I, his conjugate. But if you multiply the denominator by the conjugate, you must do it to the numerator in order not to change the term, but conveniently clean up his denominator. And so here we go. We're going to distribute as in a FOIL process here. 7 times 3 is 21. 7 times I is plus 7i. We'll scoot over and distribute the I. I times 3 is 3i. I times I is plus I squared. Now we'll distribute on the bottom here. Now remember, because it's multiplied by his conjugate, he should clean up and become just a nice real number. 3 times 3 is 9. 3 times I is plus 3i. Just scoot over and distribute the -i onto the second parentheses. -i times 3 is minus 3i. -i times I is minus I squared. We'll replace each I squared term with a -1 and immediately write down what he's equal to. That whole term is a -1. This second one here we'll replace with a -1. Minus a -1 makes this entire term a +1. Now let's see what we get. On the top here, 21 minus 1 is 20. And 7i plus 3i is plus 10i. Now that's written in our proper form, a plus bi, where a is the real part and b is the imaginary part. Now in the denominator, as we expected, the i's cancel and 9 plus 1 is 10. This one is a very good example and also to illustrate our reduction of complex numbers. And so let's go ahead and do that. We can write each one of our numerators over the denominator or factor out a 10 on top, whatever your preference. This does reduce down to 2 plus I, and that is our final answer.